Yes, hello. I am Sungchul Choi. In this session, continuing from the last session, I would like to talk about the types of machine learning. What types of machine learning are there? Before that, I will briefly talk about what I think machine learning is. When I think of machine learning, I think of it as drawing a line. And more precisely, it's about finding a line and drawing that line. In a very simple expression, I think of machine learning as drawing and finding a line on a coordinate plane. It's not exactly accurate because there are cases where it's not exactly accurate, but I think if you think of it as drawing a line, it can be relatively easy to understand. So then, what kind of line are we drawing? That's the topic for today. Broadly, lines can be divided into three types. The first type of line is regression, a regression called regression. It's similar to what we've seen before, but take a look at this data. If you look at this data with this height, can you predict the weight with this height? Can this be predicted with this? That's the kind of question we have. I only gave you the key for this data. So can we predict the weight using the height? We plotted it on a two-dimensional coordinate plane. So this represents the height. And then this represents the weight. This is commonly referred to as correlation. Commonly, there is a certain linear correlation between the two. Linear, meaning we observe a straight line correlation. We see a straight line correlation, so if the height is about 160, the weight would be approximately in the low 50 kilograms. If we draw this line, we can make predictions. So when we talk about the first type of machine learning, we might refer to predicting a line like y equals x plus b. In fact, this line can ultimately be like this, or even like this, or it could be a line like this. But regardless of the line, it follows the data predicting the y value, all based on the x value. Here it's just one, but it's a type of machine learning that predicts the y value based on the x value. We call this type of machine learning regression, or, well, some people in our country refer to it as prediction, but it seems a bit unclear. Since everything is a prediction, we will refer to it as regression rather than prediction in our lecture. It's a kind of trend line, drawing a line according to this trend. For now, we're simplifying by only talking about linear equations, but lines can also be like this, as mentioned earlier, or lines can also be like this. There is a first machine learning method for drawing such lines. We call this method regression, and it is a method of predicting the continuous value of y using the value of x. The second method is classification. Classification means categorization. Let's say we have this kind of data for classification. Given the height and weight, will it be a male or a female? I was a bit worried that this might seem somewhat sexist or something like that, but since there were no other data examples, I ended up choosing this one. I hope you can understand. So here I have represented it on a two-dimensional plane as well. Men are marked in orange and women are marked in light blue. Is it sky blue? No, it's not sky blue. Yes, I have marked it like this. By marking it this way, can we draw a line that can actually separate them? If we are asked this question, finding this line is considered the second method of machine learning. Well, you can draw a line like this. Let's assume we are drawing it as a straight line. So if we say this straight line is y equals x plus b, when it is greater than x, plus b, well, this area is considered male. If it is less than this, well, it is considered female. It would be minus ace. Anyway, in this way, you can draw a line to distinguish between male and female. In this case, 1, 2, 3 are incorrect cases, and here too, 1, 2, 3 are incorrect cases. Of course, you can draw a line like this, but for example, you could also draw a line like this. This line's, yes, you could draw a line in this way, right? Yes, the line looks a bit strange. Well, like this. Oh, I drew it wrong. Oh, let me draw it again. Yes, for example, if it's above this line, it's male. If it's below this line, it's female. Doing it like this, oh, I can't draw this line at all. You can draw a line like this as well, right? You can draw a line like this. And by drawing such lines, the value of some y is classified, whether it's male or female, or whether it's Korean, American, or Japanese, or whether it's a Chinese middle school student or high school student, finding data in this classification form like this. Depending on the value of x in this classification form of data, the data is in this form. Finding this form is what we call classification in Korean. In English, it's commonly referred to as classification. This is the second type of machine learning. Lastly, as mentioned before, although we often draw it as a straight line, it doesn't have to be a straight line. It can be drawn like this. And actually, if you look into it later, you'll find that sometimes such lines are drawn as a result. This doesn't come from an equation per se, but when you directly apply it to the resulting equation, it comes out like this. Later, when you learn about decision trees, you'll see that decision trees can draw lines like this in many ways, and it can be drawn like this as well. So, by drawing various types of lines, you solve classification problems, finding Y data with categories. This can be seen as a classification type problem. Now, thirdly, it's clustering. Clustering is, well, previously we talked about finding the y value when given the x value. It's a kind of function approximation where the function f(x,d) is given, and it was about whether the y value matches correctly. But this time it's not like that. We're just given the x value. We're only given the x value, and from there, let's try to form about 3 basketball teams. How should we divide them? For example, we would do clustering like this. We gather them in clusters like this. Cluster. By gathering groups like this, we can say, hey, we form teams of people with similar heights and builds, and we can play 2-on-2 basketball. And finding a way to divide them like this is exactly what a clustering problem is. It's slightly different from the previous problem. There is no prior information. Saying there's no prior information might be a bit incorrect, and as there can be multiple data points for x in the data. You're given data like height, weight, gender, and you're asked to divide it. This task is commonly referred to as clustering or grouping. This is a very general term. So, as you all might have already understood, there are mainly 3 types. The first is regression. There is regression analysis, and the second is classification. Yes, this is when you have y data. In these 2 cases, you have y data, and you're asked to infer this y data from the x data. When given x data, what will the y data look like? Find a model for that. And then there's clustering, where you're given only x values and asked to divide these x values into n groups. Group them into n clusters. These types of problems are the main issues in machine learning. So, to summarize, there are these 3 types. There are regression, classification, and clustering. In the case of regression and classification, you are given data x and asked to predict the value of y, where this y value is a continuous value. It could be any real number, like from 1 to 100. Usually, it's a real number. The concept of real numbers could be like 1.1, 1.2, or 0, 0.5, and so on. The second is classification. In the case of classification, you can think of it as discrete values, categorical values. Later, I will explain in more detail about continuous and discrete values, but for now, think of categorical values. For example, spam classification, like whether it's spam, 구워, tates or not, spam or ham, things like that. Yes, this is a kind of joke. It's a spam email. It's not a spam email. This person is a game abuser. Yes, in when we say abuser, it refers to people who use illegal rules in games to cause disruptions. They are an abuser. They are not. Or it belongs to the sports section of a newspaper article. Or it belongs to the entertainment section, not the sports section. Or it belongs to the politics section. Finding these kinds of things is what we call a classification problem. A regression problem deals with continuous values, while a classification problem deals with discrete values, essentially finding category data. And clustering involves being given only the x data and finding the best way to divide it into n groups. For example, when data is scattered like this, how many customer groups can it be divided into? And based on time, purchase time, or type of product. Type of product. Then, given only data like the amount, try dividing the customer groups into several parts. Clustering is what makes it easy to find these things. So commonly, when dividing two and one piece of data, it is generally said that there are three types of methods in machine learning. In fact, these three types are broadly divided into two categories. Supervised learning is also commonly called supervised learning in our language. It is also called teacher learning. While there is debate over which term is better, the term supervised learning is more commonly used. So it is called supervised learning. There is regression, classification, and data for Y. Next is unsupervised learning, also known as unsupervised learning or unsupervised learning. It is called non-teacher or unsupervised learning, and in this case there is no Y data, so you have to categorize it on your own. And now there's a lot of interest in reinforcement learning, which was used extensively in AlphaGo and recommendation systems, which in some ways are similar to clustering. In any case, these are categorized and sometimes added as well. However, the most representative ones can be divided into three categories: supervised learning and unsupervised learning. These three categories have their own intricacies within them, which is quite fascinating. If you visit this site, you'll find an illustration showing that in machine learning, there are supervised learning and unsupervised learning. In supervised learning, there are problems related to classification, which involves categorizing, predicting continuous values, and clustering. We can see that there are various algorithms for these three types. Here, the algorithms we will learn include things like this. Then, linear regression, and a bit of neural networks. We might explain this later if time permits, and it seems like we're learning almost everything. We'll learn things like this. It seems we won't be learning about highlights, hierarchical means, or hidden Markov model. Here we might learn about k-means. We might also cover Gaussian mixtures, but probably not. So by learning these two, and maybe one of the others, we will be covering a lot of algorithms in the future. So up to this point, we've learned about the types of machine learning. The types of machine learning are broadly divided into two categories: supervised learning and unsupervised learning. Supervised learning is further divided into regression and classification, while unsupervised learning is divided into clustering. Next, you should also remember that reinforcement learning, known as RL, and problems like recommendation systems are included in this. It wasn't a difficult topic, right? From next time, there will be some content that goes a bit further. From the next session, we will return to more challenging content. Thank you.